Welcome back to the third video in our series on normalization theory. The first two had to do with Guidelines 1 and Guidelines 2. This series is based upon a textbook by Al-Masri and Navath, Fundamentals of Database Systems, 6th edition. So let's pick up where we left off in our last video. In some schema designs, we may group many attributes together into a fat relation. If many of the attributes do not apply to all tuples in the relation, we end up with many nulls in those tuples. This can waste space at the storage level and may also lead to problems with the understanding of the meaning of attributes and with join operations at the logical level. Another problem with nulls is how to account for them when aggregate operations such as count or sum are applied. Select and join operations involve comparisons. If nulls are present, the results may be unpredictable. Furthermore, nulls can have multiple interpretations, such as the following. The attribute does not apply to this tuple. For example, visa status may not apply to U.S. students. The attribute value for this tuple is unknown. For example, the date of birth may be unknown for an employee. And finally, the value is known but absent. That is, it has not been recorded yet. For example, the home phone number of an employee may exist but may not be available and recorded yet. Having the same representation for all nulls compromises the different meanings they may have. Therefore, we may state another guideline. Guideline number 3. As far as possible, avoid placing attributes in base relations whose values may frequently be null. If nulls are unavoidable, make sure that they apply to exceptional cases only and do not apply to the majority of the tuples in the relation. Using space efficiently and avoiding joins with null values are the two overriding criteria that determine whether to include the columns that may have nulls in a relation or to have a separate relation for those columns with the appropriate key columns. For example, if only 15% of the employees have individual offices, there's little justification for including an attribute office number in the office relation. Rather, a relation, let's say offices with the social security number, the office number as attributes, can be created to include tuples for only the employees with individual offices. Consider the two relation schema ImpLox and ImpProject1 in this example, which can be used instead of a single ImpProject relation that we saw earlier. A tuple in ImpLox or LOX means the employee whose name is ename works on some project whose location is P location. A tuple in ImpProject1 refers to the fact that the employee whose social security number is SSN works hours per week on the project whose name, number, and location are P name, P number, and P location. Suppose that we use ImpLox Project 1 and ImpLox as base relations instead of ImpProject. This produces a particularly bad schema design because we cannot recover the information that was originally in ImpProject, right here, from ImpProject 1 and ImpLox. If we attempt a natural join between ImpProject 1 and ImpLox, these two here, the result produces many more tuples than the original set of tuples in ImpProject, as shown here. In figure 15.6, the result of applying the join to only the tuples above the dashed lines is shown. This is to reduce the size of the resulting relation. Additional tuples, those indicated by the asterisks, are called spurious tuples because they represent spurious information that is not valid. This brings us to guideline number 4. Design relation schemas so that they can be joined with equality conditions on attributes that are appropriately related pairs, primary key, foreign key, in a way that guarantees no spurious tuples exist. Avoid relations that contain matching attributes that are not foreign key, primary key combinations, because joining on such attributes may produce spurious tuples. Well, we were able to knock out 2 more guidelines in this short video. It's a good place to stop. We discussed guidelines 3 and 4, and during that discussion we mentioned spurious tuples. So let's make spurious our mystery word for this video. So go ahead and submit spurious, and then go check your knowledge on the material covered in this session. And when you're ready, come on back and we'll proceed to the next in the series on normalization theory.